Hi, my name is Nicholas Renteria. I am the editor and recorder of this project. A little bit about me is I am the varsity cross country and track and field team. I was rejected from the varsity volleyball team in the film club, and I make my own films, and that is all for me.
That's good.
Okay.
Hi, my name is Ethan Dela Cruz. I am a senior in MSET, and a little something about me is I'm the ASB Executive President, Liturgy Director, to Varsity Volleyball, part of the esports production team. And right now I am working on the Pike Creek.
Hello, my name is Paul Tapia. I'm a senior here at Bosco Tech. A little bit about me is that I'm the ASB Executive Treasurer. I'm also on our varsity golf team, and my job for this project is to cast the aluminum and brass medal.
So my name is Jimmy Santana. I am a senior in MSET. A little bit about me is I'm on the exec board as secretary. For this project, I am making the concrete.
So what exactly are we doing here? We're going to take 4 materials here. It's going to be aluminum, concrete, concrete, and brass. And we are going to do a compression test. What that means is we're going to have one big boy machine to try to squash the sample down. This sample is going to be a 2x2x4. I'm going to sample right here, and they're all going to be the same. So that means their density is relative to the weight. As we can see by the stats over here, brass is almost 4 times more heavier than aluminum, making it more dense. Predicting that brass will be the most dense and will be able to withstand the most pounds of pressure.
Wow, Ethan, all of this was really informative. How does this relate to MSET?
I'm so happy that you asked, because MSET stands for Material Science. And guess what we're doing? We're measuring 4 different materials, and we're just comparing and contrasting to see which would be better for a certain application.
Now we're going to be filming our crushing of the aluminum sample back to 0, the speed, and here we go. Okay, yeah. Held up pretty strong. It kind of compressed a little bit though. It used to be more like right here, compressed, but aluminum, it's very dense, very solid. So fortunately we cannot test it over 60,000 pounds, but I was aluminum. It's time for our brass example. All right, here we go. Probably have to stop it. It's not shrinking. All right. So in conclusion, while the other materials we were able to test, unfortunately we were not able to fully test both metals, but they both exceeded over 60,000 pounds. Now, as you can see, the size difference, it's not by much, but you can see that the brass is a little bit of a more advantage than the aluminum. It definitely weighs a lot more than the aluminum does. In our conclusion, brass is a stronger material in terms of compression strength than aluminum.
So right here we have our pie cream made out of sawdust, and right here we have our pie cream made out of toilet paper. Both of these have been sitting and freezing for around 2 weeks, so we'll see how they do under compression.
So now we're going to be moving on to our concrete sample. So it's gonna be the same thing. I have to adjust the meter, set it to 1, speed, all the way to 0.6. You can watch it get crushed.
The results are in and you guys watch the footage. Let's take a look at that. Aluminum maxed out our machine. Over 60,000 pounds it withstood. Concrete, 5,100. Paper piping, 1,200. But then the sawdust made up for it with 15,000 pounds. And mind you, brass is almost quadruple the weight of aluminum. It also maxed out our machine, but we'll never know how much it did. But what separates aluminum and brass is that the brass barely shrunk by about 1/4 of an inch, while aluminum got minimized down to 1/2. So our hypothesis was right. When are we ever wrong? Brass is the true winner.